I'm trying something new I thought you might like. I don't know. In addition to having some solution guides, seeing how I would break down each problem or whatever. I'm doing this at home. The girls are running around, so if you hear screaming, well, you know, turn it off. So right now this is extra credit. In the future it might not be. So we're going to take the derivative of each of these with respect to x. Shoot, looking through that. At least these four, the input is x, so there's nothing crazy there. Nothing crazy on any of them, so we're just doing the normal derivative. You'll also notice that I've attached the results or something like that. I like that better than solutions. I think of a solution as kind of how to do something. All right, let's make sure we're doing blue. Blue is so much better. Okay, here we go. So f of x is sine of 2x cubed, and I think maybe the reason you're watching this is you're struggling with the structure. So the outer function, you know, if we had done, well, let's not do teaching. Let's just do solutions. So the outer function is sine, so the derivative of sine of something is cosine of that same something. That something is 2x cubed, which has a rate of change of 6x squared. Okay, let's see how we did compared. Cosine 2x cubed times 6x squared. And I guess they rearranged, but we're worried about, you know, doing this. Now, maybe we should rearrange, and if you think about why this is better, you know, having the 6x squared out front makes it very obvious that the input to the cosine is 2x cubed, and that 6x squared has nothing to do with anything else. Maybe we can make this even bigger. Okay, y is equal to tangent of 5x cubed in a similar structure to the last one. That 5x cubed is an input to tangent. It says derivative with respect to x, so we can write dy dx or y prime. I'll do dy dx. The derivative of tangent of something is secant squared of that something. And this something is 5x cubed, which has a rate of change of 15x squared. We'll assume, to make everything match, the simplified version, or the best way to write that, is 15x squared out front times secant squared of 5x cubed. Cool. All right. Okay, so hopefully now you're seeing the structure that if we had parentheses, that 4x to the fifth is inside of secant. Maybe we'll do y prime this time. The derivative of secant is secant tangent. And careful there because each of these secant and tangents has the same input, 4x to the fifth, which has a rate of change of 20x to the fourth. So let's see, how are we going to rewrite that? We can't really combine secant and tangent. So 20x to the fourth, secant, 4x to the fifth, tangent of 4x to the fifth. Cool. All right. 5x to the fifth is the input to cosecant, so dy dx is negative cosecant stuff, cotangent stuff, and that stuff is 5x to the fifth, which has a rate of change of 25x to the fourth. So dy dx is negative 25x to the fourth, cosecant of 5x to the fifth, cotangent of 5x to the fifth. Ooh, okay, so a little bit of an extra challenge here. The girls are getting wild over here. Okay, so, you know, the structure I see, obviously this is one function, and this is another function. So we're going to use the product rule, and when we get to the derivative of the cosine of x squared part, obviously a chain rule there. So let's see, the derivative of a product of two functions is the first function, times the derivative of the second function. The derivative of cosine is negative sine of that same x squared, chain rule, times the derivative of x squared 2x. Then we'll continue the product rule. The second function, cosine of x squared. Maybe I'll write it like this to make sure that when I multiply by the derivative of the first function, let's see, what's that going to be? 10x to the fourth plus 0. I just wanted to make sure it looks like x squared and 10x to the fourth are unrelated. I don't know if I want to rewrite that. Maybe I want to factor stuff out, but that's kind of ugly. I think that's good enough. If anything, what would I do? I'm just going to leave it like that. You're not going to get a good simplification. You could probably factor out, well, at least an x from the whole thing and maybe a 2, but I'm not worried about it. All right, so what do we have to worry about here? A quotient of two functions. The derivative of a quotient of two functions is the denominator. I think it's good to have parentheses, times the derivative of the numerator. Negative 4x, derivative of negative 5 is 0, minus the numerator. Times the derivative of the denominator. Derivative of cosine is negative sine, and I think I'm just going to change a plus there. Of the same 2x cubed, chain rule, times 6x squared. Don't forget, all over our denominator, cosine of 2x cubed squared. And we really can't rewrite much there either, so I think I'm going to stop. All right, 2 more. Oh, thank goodness. This is a lot cleaner, but maybe we should rewrite f of x is, come on over, Debbie, sine of x to the 5th, and then we're cubing that whole thing. What's up, baby?
Look, I did this into a book.
You can sit and watch. Okay, so there we go. And so the derivative, we have to deal with the cube first, of something cubed is 3 times that same something squared. Our something is sine of something else, which has a rate of change of cosine of that same something else. That something else is x to the 5th, which has a derivative of 5x to the 4th. So this one does clean up nicely. I'm going to bring that 5x to the 4th from the back out front, and we're going to have 5 times 4 is 15x to the 4th. Sine squared of x to the 5th, cosine of x to the 5th. I think we just have one more. Cool.
What?
And, okay, looking at structure here, exponent 2, that's just on the input. So we deal with the derivative of cosine first, negative sine of the same input. And that input is negative 3x squared plus 2 squared, which has a rate of change of 2 times stuff. And that stuff is negative 3x squared plus 2, which itself has a derivative of negative 6x. Does that clean up much? So I think I'm going to do the negative on the 6x and the negative sine, and we'll just write that as 12x sine of negative 3x squared plus 2 squared. Oh, I should put that at the end. Okay. And then times negative 3x squared plus 2. My brain, I guess, had that inside of a sine or cosine. Cool. Let me know if that helps.